In this video, I'm going to cover the deployment process of deploying a full stack application using a complete pipeline from GitHub Actions to Docker to DigitalOcean. There are also some other peripheral technologies included there, like setting up Nginx and a few other things. So there's a lot to cover, and this is going to be a two-part video. If you are new to this channel, welcome. My name is Gwen, and I do lots of programming videos on web development and other tech-related content. So if you're interested, don't forget to subscribe. Now, some of the technologies and the stack I discuss in this video go kind of deep. So I'm going to give a broad overview of the whole deployment process that I'm employing for this application, and then kind of go into each different piece of it and try to break it down as much as possible. Now, the stack that I am using in this video, I have used at a few companies now, at startups, and it's been working really well for me. It's kind of the baseline setup that I always use that I can build off of and make it a little bit better. And I'll also discuss that later on in the video. Here is the site that I'm going to be deploying. If you've been following me, you know that I've been live streaming the building of this site since January off and on. So this is kind of a labor of love project that I really want to exist and to share with people. It's definitely in a beta version now, and I am continuously trying to make it better. So feel free to leave me comments and feedback about the site as well. And I will link the GitHub for it in the description below. First, I want to do a broad overview of all of the steps in this whole deployment process so you can kind of see what it's like end to end, and then I can dive in to each step in more detail. So first, I built these apps in a monorepo. So it's basically the front end and the back end contained in this same GitHub repository, just in separate folders. So the back end is a Django REST framework API. And then the front end is a regular Vue.js application. So for each of these, the back end and the front end, I created Docker files for each app to be able to run a server and spin up and run on its own port. I want to use these Docker files to construct Docker images, so I'm using a GitHub action for that. Now, GitHub actions are found in a special folder called workflows, which is inside the .github directory. And each workflow is basically a YAML configuration file that automatically executes based off of whatever events I set. For example, in this prod.yaml file I created, I only have this action running when there's a PR or code gets merged into master. So it doesn't run if I'm working on any other branch. And what this file does is it will look at the Docker files in both my front end and my back end and build two separate Docker images, and then push those images to Docker Hub. Now, Docker Hub is a registry for Docker images. It's just a place where you can store Docker images. It's sort of like GitHub, but for Docker. So you can actually search and find just about anything that's made into a Docker image already. And you can also put your own projects into Docker images, which is what I am doing with this project. Now, I have these two images on Docker Hub, the front end and the back end for my application. And so that brings me to the second part of the deployment process, which starts with DigitalOcean. So on DigitalOcean, I need to spin up my own server, which is called a droplet. So I basically create a droplet, and then there's three things that I need to do in no particular order. The easiest low-hanging fruit is set up a domain. So you actually have to buy a domain name somewhere else, like Namecheap, and then just point the name servers at DigitalOcean, and then from there you can manage that domain from inside of DigitalOcean. Now, I need to SSH inside of the droplet so I can start setting it up. And first I'm going to install Nginx and configure it so I can receive traffic from the web on port 80 or port 443 for HTTPS or HTTP traffic. And then I can use Nginx to route that traffic to my app that is running on the server. Of course, to use HTTPS, I have to generate an SSL certificate, which I do with Let's Encrypt. And for running my app, I created a Docker Compose file. And what this Docker Compose file does is pull 4 different Docker images from Docker Hub. So it pulls, of course, my front end and my back end as images, and then it also pulls MongoDB, which is my database, and then it pulls a 4th one called Watchtower, which I'll get to in a second. So I pulled those 4 images from Docker Hub with my Docker Compose file, and then my Compose file is also set up to run those Docker containers. So it spins up all 4 Docker containers, exposes the correct ports that I need, and then Nginx can properly route traffic to my Vue.js application on the server. And then the Vue.js application talks to the backend, and then the backend can talk to MongoDB. And now Watchtower comes in because it's basically a Docker container that is always running and watching for changes or updates in the other Docker containers. So for my front end and my back end, every time I merge code into the master branch, my GitHub Actions automatically run and they push those new images to Docker Hub. Watchtower then sees those updated images on Docker Hub, and then Watchtower pulls the images to my DigitalOcean server that I'm running, and it basically stops the old container with the old code running, and it spins up the new container with the new updates that I've made. So those are all the steps that I have to partially automate my DevOps setup. There are still, of course, a few improvements I'm going to make that I'll make a future video about using Ansible and a few other things. But I'm overall very happy with this setup so far. It's fairly reliable, and I think it's a good base point for me to keep improving and building a more robust DevOps system for this application. There are a couple of accounts that you will want to set up. I'm assuming that you have a GitHub account. If you don't, go ahead and sign up for one, as it only takes about 2 minutes. The second account to sign up for is Docker Hub. Docker Hub is a registry for Docker images. We'll be talking a little bit more about Docker later on. The next account is a DigitalOcean account. Now, GitHub and Docker Hub are, of course, free, but DigitalOcean, you will have to sign up with a credit card. That being said, you won't have to pay anything. You only pay for the servers you have running. So if you just want to try this out, enter your credit card, spin up a server, and you can shut it down right after. And I don't believe you will even be billed for it, because I think your bill has to get up to at least $1 before they charge you. The last step, and this is totally optional, is that you can buy a domain if you want one. You don't have to get anything fancy like a .com or .io domain. You can literally buy $2 domains if you just want to practice setting them up and using them. So what is Docker? Docker is basically software that can create these VM-like containers that make it easier to build and deploy applications. The difference between Docker and standard VMs are that Docker is much lighter weight and more portable, and it's easier to spin up for testing or building applications. Now, why might you want to use Docker containers for your application, either for local development or for your deployed application? So Docker containers keep all of the dependencies that you need for your application inside of the container itself. For example, if you're building a Python application, then the version of Python that you need installed will be available inside of that container, and then you run your application on that container with all of your other installed dependencies, and it's a tailor-made virtual environment just for that application. Now, if you want to run that application on another operating system or have other developers work on that application or deploy it somewhere in the cloud, it really doesn't matter what the underlying operating system is or what dependencies are available on the operating system itself, because everything that you need to run that application is contained inside of the Docker container. Now, sometimes you do need to link to other services that are running, for example, a database. In this video, the application that I'm working with actually links to a MongoDB database, which is also running in a Docker container on a different port. And so I expose a port on each Docker container, and that's how each container can work with or communicate with each other. I have the front end running on a port 8080 right now, which connects to the back end, which is running on port 5000, MongoDB, which is running on port 27017, and then in the future, if I need Redis or Elasticsearch or something else like that, I can easily spin up a container for those things as well. I'll link this article on docker.com to learn more about containers if you're interested. There are also a few different pieces to the Docker ecosystem. There is Docker Desktop, which is an application that you install on your computer, which gives you tools to build and manage Docker containers. If you're going to run Docker commands from your terminal, you should have this installed on your computer. As I mentioned before, Docker Hub is a container registry for Docker. It's a service where people host Docker images, and there's a very large number of images that are already hosted here available for the community for free, like MongoDB image, Python image, Node image, depending on what application you want to spin up or what you want on that particular container. And so what images are these templates that are used to build Docker containers. So in this tutorial, we are going to, as I mentioned before, spin up images from our GitHub Actions pipeline, push them here to Docker Hub, and then eventually pull them to our server so we can run Docker. There are definitely other Docker registries. I've used the GitLab Docker registry before, and I believe GitHub has one as well. But I found that Docker Hub is the easiest one to use, and it also gives me a number of free public containers. It lets me host any number of free public images, which is perfect for this app I'm building today because it's already an open source application. So I want to walk through the two Docker files that I need to create. And you can see I have one Docker file for my backend, and also I have one Docker file for my front end, which is my Vue.js application. So they will both be running in two different Docker containers when I spin them up. I'm going to go over these Docker files line by line and start with the backend because it's a little bit more simple. So you can see Docker files are constructed with these commands providing for synchronous line-by-line execution. The first thing you always want to do is choose what image to build off of as a base image. And you can find all of the base images on Docker Hub that are available. So for this one, I'm choosing a Node image, and LTS means long-term support, and then Alpine. So Alpine is a very small Linux distribution. It's much smaller than other distros. So this is an official Docker image with Node already on it, which is exactly what I need to run my application. And that's really the only dependency that I have for this application. So now I need to set a working directory, and now this is the directory inside of the Docker container. So you could use some other directory wherever you prefer to have your application. I've just always used user source app. Now that I've set my working directory, I need to put my application files inside of that directory so that I can start building and running this application. So I can use the copy command, and what this does is copy files from my local directory into the Docker image. So normally I could just have something like dot, meaning copy the files from the current directory into the current working directory inside the image, which I already set as this. So dot / is just a shorthand for working directory, basically, as the second command. But the first command is always the current directory that's not inside the Docker image. But I can't actually just copy all of the files from the current directory into the image because I'm actually using a Docker compose file that's in another directory that's in the parent directory. So I have to tell it, go into the curriculum backend and look at the place with the Docker file and then copy that package.json and package.lock.json over to the Docker image. And now once they're copied onto the Docker image, I can now run npm install, and of course that will install my npm packages and create my node modules inside of Docker. And then I copy all of the rest of the files into the working directory in Docker. This command is only for debugging. So here I'm just listing all of the files and folders that I have copied inside of the working directory in Docker and making sure that everything copied over correctly. And I found these commands to be extremely helpful when I'm using Docker because sometimes it's really easy to not realize which files you've copied over, or if you copied from the right directory, or if there's something there that you don't expect. And then I run my command to build for production. So now for the front end, and you can see this is the same. I start off with the same kind of image. I set up the same working directory. And this makes it easy to know that no matter what container I'm looking at, I always know where I've copied my files because I just use the same one all the time. I copied the package.jsons from this file into that working directory. Here I'm running 2 debug commands. Now, the front-end apps seem to be a little bit more finicky because I have to build all of the static files, the HTML, CSS, and JavaScript, and then I actually built a custom node server to run the front-end application out of the dist folder and serve it on port 8080. Because when you use something like Webpack for Vue or React or whatever, you get a nice dev server, but then when you build for production, it's just building static files. So then you have to serve them up with some kind of server or allow users to access them directly or something like that. And here I'm actually resetting my working directory because all of my building and actions I wanted to do inside of here, but now I have the dist folder and the node server that I've copied in the dist folder, and I want to serve up those static files directly from the dist folder. I don't need any of the files outside of that anymore. A lot of the information that I got about Dockerizing Vue.js applications actually came from this official Vue.js cookbook Dockerize example. It goes through a lot of these details step by step what each line is doing in the Docker file. I think there are only a few differences from what I have, and it uses this library HTTP server, whereas I'm using a custom file because I'm going to build off of that file. And it also goes over the Docker commands to build and run the Docker container. And I am actually going to go over those in the next video when I'm actually inside of my DigitalOcean server and building and running these Docker containers. But I'll link this in the description below for you to see. So I'm in my GitHub repo right now, and you can see that my default branch is this dev branch, short for development. And so this is the branch that I've been working off of and I merge new code into. And then when I have some new updates or features on this branch that I think are ready for deployment, I then take them and merge them into the master branch. And then when I merge into the master branch, it automatically runs the GitHub action that I have set up. So it's in the .github/workflows folder. And GitHub automatically looks in this folder for any tasks to run whenever an event occurs. So whenever there's a pull request or a push or anything. And the task that I have running here is basically triggered on a pull request event to master or when code is pushed into master. Now, the name of this isn't really important right now. If I had more automation processes, then I could pick out which one is running when, but I only have one now, so I give it a descriptive name anyway. So after it's triggered on one of these events, it basically runs any of the jobs that I have listed here, which are 2 jobs. So build and deploy the back end and build and deploy the front end. Now, GitHub Jobs basically spins up an environment to run this code in, and I'm telling it to spin up an Ubuntu environment and then take these steps once Ubuntu is ready. The first thing is to check out the code. You're going to be doing this a lot, and you can see that I do this with both of my build and deploy steps. With GitHub Actions, there's probably somewhere I can put something like a before each and tell it to just run this before each so I don't have to duplicate this code, but I haven't looked into that yet. I'm not running a test suite or anything right now, so basically all I'm doing here is build and pushing the Docker image. And so this is an action that somebody wrote, and I am using it here. So GitHub Actions actually has this whole marketplace of tons of actions that you can just plug and play into your workflows. Instead of writing custom commands or shell commands or whatever else I would be doing, I just use this action that's already created. I give it some context, like my Docker username and Docker password. I tell it where the Docker file that I want to build from is, give it the name of the repository on Docker Hub that I'm pushing to, and then any tag that I want to associate with this Docker image. So where do these secrets come from? GitHub secrets are something that you can add in the settings for the repository. You can basically click here to add these variables, call it whatever you want. Usually it's all caps with underscores for secrets. And then anything you add here will be available in any GitHub action on the secrets object. So I can just do secrets dot whatever secret, like Docker username and Docker password, which are the username and password for my Docker Hub account. Now on Docker Hub, you can see I have my username, which is just an old screen name I used to use, fuse365/curriculum-front, and fuse365/curriculum-back. These are the locations for my repositories on Docker Hub. And you can see once I log into my account or I authenticate with my account, I can push this new Docker image or an updated image to that repository on Docker Hub. And you can see I'll go into one of these. You can see some information about it. There's not a lot here. I haven't put much information. But if I go into tags, I can look at the latest build for any tag. Docker tags are a way you can tag different builds of the same Docker image to differentiate between them. You can kind of think of it like Git branches on your Git repositories. So you might have feature branches, and then you might have dev and staging and master. And each of those branches will have different updates and be in a different state code-wise, or maybe different versions. And it's really convenient to do the same thing with Docker containers using tags. You can differentiate different versions, different builds, different environments, etc. It's not exactly the same thing as branches because technically tags are just aliases. Git also has a tagging system. So if you look at repositories on GitHub and NPM, you can see how different repos use tags. I used Git branches as an example here because everybody uses Git branches and I don't think that many people use Git tags. Hopefully that explanation was clear. I don't have any special tags in here. I'm probably going to have different tags once I make different environments. For example, I might have a staging environment and a development environment and then a production environment. In that case, I would have different tags. I would have a production tag, a dev tag, and a staging tag. Right now, I'm just using the default tag, which is latest, which is just used by Docker for the latest update of the image. Here I can also see the file size and see the file size broken down piece by piece. Now, if you want to create a repository on here, it's very simple to create. Just click Create Repository, and it's going to be your name / whatever the repository name is. You don't need to give it a description. You can connect automatic triggers to build if you want to. I don't think you need to do this if you're using GitHub Actions though. And that's basically it. You just create it, and initially it's going to be an empty repository. There will be nothing in there until you push something to it. And that's where GitHub Actions comes in, because this action I got from the marketplace will always push my latest code on master to that Docker Hub repository. Now I am being very explicit in tagging it latest here, but even if I didn't include the latest tag, Docker would automatically give it the tag of latest. I'm just including it here because eventually I'll want to tag it with other things. It's not actually a good idea to use the latest tag in production, so eventually I won't be using that anymore. I'll link more information about the latest tag in the description below. If you want to take a look at this action, it also goes over all of the options that you have here and the complete API for it with some examples. Thanks so much for watching. I hope you enjoyed the video and that you are doing well. Don't forget to like, comment, and subscribe. And I will see you in part 2 of this whole deployment process.